Continuing on in our investigation of the OceanGate Titan submersible implosion, we're going to answer more of your tough questions that you've been asking all week here in the comments on the videos. And we're also going to take a second look at some more potential manufacturing defects that have come to light in the last few days. So I want to review here with you this picture that was just released over the weekend from the RMS Titanic Historical Society. This sonar map, most of it was made actually coincidentally by none other than P.H. Nargeolet, who was the guide on the Titan submersible that had the implosion here. So he died in the implosion. So his work here is still lingering long beyond his death. And so what they did was they created this map to help the investigators to show them where everything landed. So here's where the Titan debris field landed. Now, don't make anything into this. You're going to probably see idiots on TikTok saying, here's the debris. There's nothing in the picture. This is an old sonogram. All they did was put a circle here to highlight where the approximate area was that they found the Titan debris in relation to the Titanic. There's not going to be any photographs of any debris there. Nothing has been released yet as far as we know. And then as you look over here, this is where the Titanic bow is. Now, you might recall the Titanic broke up in two pieces and came crashing into the mud at the bottom of the Atlantic at 35 miles per hour. Now, the reason why they have these two delineated here is the forward hatch on the bow is right here on the Titanic, but the hatch cover must have come loose when it slammed into the ground, and it's over here now, probably about 100 yards away. And then I've already received questions from people about what these rafted boulders and rocks mean here. Are these? This is a great example of one. This is where you get a whole bunch of rocks that just ended up frozen together on a piece of ice, and it's floating around like a raft. And then what happens is over time, as these pieces of ice melt, the boulders just drop down below to the bottom of the ocean. And so that's what they're referring to here, is all of these ice rafted boulders and rocks. They were dumped by different icebergs in that area that melted over the years. Okay, so this gives us sort of a lay of the land of how far away the Titan debris field is. I think they said it was something like 1,600 feet or somewhere around 400 meters away from the bow. Now, one question that has really bugged me since the very beginning of this whole ordeal concerns Paul Henry Nargeolet, otherwise known as P.H. Nargeolet. So my question is why did P.H. Nargeolet continue to go down on these exhibitions with OceanGate? I mean, he's probably the foremost expert on submersibles, and he's been down on the Titanic over 30 times. Certainly P.H. of all people would know that there's something wrong with this submersible when all the other experts already were telling Stockton Rush that there's something wrong with it. So why did he continue to keep on going down? In fact, even my friend Don was a producer who did a number of documentaries and stuff like that for the Titanic channel. He knows PH, and he knows him really well, and he said he never would have gotten on that sub with the crackling noise on it. So let's take a look into that. Back on July 1st, reporter Ben Taub did this article here on the New Yorker magazine. It's called "The Titan Submersible Was an Accident Waiting to Happen." And in this article, he interviewed a number of people close to Stockton Rush. Here he also interviewed friend Patrick Leahy, who is the CEO of Titan Subs, P.H. Nargeolet, who's probably the world's foremost expert on the Titanic. He's probably done over 30 dives on it. Their guide here on this trip as well. And his friend, Patrick Leahy, was quoted here in this article as, because he's a good friend of P.H.'s, and he said right here, for the Five Deep's crew, Nargeolet's legacy is complicated by the circumstances of his final dives. I had a conversation with P.H. just as recently as a few months ago, and he says here, I kept giving him blank. I put the X's there to filter out the expletives, but he says, I kept giving him blank for going out there. I said, PH, by you being out there, you legitimize what this guy is doing. It's a tacit endorsement, and worse than that, I think he's using your involvement with the project and your presence on the site as a way to blanking lure people into it. And so the answer that he got back from P.H. Nargeolet was that Nargeolet replied that he was getting old, he was a grieving widower, and as he told people several times in recent years, if you have to go, that would be a good way. Instant. Leahy then replied back saying, I said, oh, okay, so you're ready to blanking die? Is that what it is, PH? And he says, no, but I figured that maybe if I am out there, I can help them avoid a tragedy. But instead, he found himself right in the blanking center of a tragedy, and he doesn't deserve to go that way. And Leahy then went on to say, I loved P.H. Nargeolet. He started choking up. He was a brilliant human being and somebody that I had the privilege of knowing for almost 25 years. And I I think it's a tremendously sad way for him to have ended his life. Now, I'll put a link to this story to the New Yorker down below in the video description for you. You should read the full article. It has a whole lot of just unbelievable details and interviews with different people involved here. Okay, now here's something else that we're looking at this week too. If you look back at this manufacturing video that OceanGate put out a few years ago when they were building the Titan submersible, take a look again here when they were gluing together the titanium ends onto the carbon fiber cylinder. There's two things I'm seeing here. Number one, look at this technician's hands. I don't know why he's not wearing gloves. This should be a reasonably sterile environment. And you can see now he's putting his hand on the stupid titanium ring. Now let's just contaminate that some more with our fingerprints and our oils from our hands. And then one other thing that you really need to consider here is these titanium rings. Before you put any type of adhesive on there, how is adhesive going to stick onto a good shiny smooth metal? So what I don't see here, and I didn't even hear them mention, is did they bother to do any kind of abrasion or sanding on there, or do an acid etch or something to rough up that surface to give the adhesive something to just cling onto? That's what you're missing here. And so I think that probably explains why, like I've showed you in some of our previous videos, when they pulled up some of the debris from the bottom of the ocean floor, why the titanium rings are smooth and it looks like they were 100% picked clean of any of the carbon fiber material, not even little chunks that might have been left glued. That glue over time, I think with the compression cylinder constantly under compression and expansion as it goes down and comes back up, and you get all of this cyclic fatigue going, I think also that adhesive likely just cleanly stripped itself right off of those titanium rings. Now here's another good engineering channel here on YouTube. It's a Joe's DIY Lab. Now he's a former Boeing engineer, and he's been at some of these places when they were building the carbon fiber at Boeing. And one of the things he pointed out was that if you notice, this doesn't appear to be done in a clean room, and we don't even know if they used an autoclave. In fact, he was pretty shocked that they did not use an autoclave. So if you're not familiar with an autoclave, here's an example of one that Boeing took delivery of. This is what they used to put the carbon fiber product inside there, and they close it up here with this door and they put it under high heat and pressure, and this is what's supposed to help cure the epoxy. And that's another question too, is, I mean, how do we even know whether they put the epoxy on and at the proper rate or the amount that it was supposed to be? You see them applying it, by hand with a squeegee. Is that entirely accurate? Using the inaccuracies of the human hand. So these are questions that come into play here. If this was a wet type of an application when they were spinning up the carbon fiber onto the cylinder, why wasn't the carbon fibers here pre-wetted? But why didn't they pre-wet it? So there's the $1 million question right there, folks. Why didn't they pre-wet the fiber, or should it have been pre-wet? What they're supposed to do is, under maybe computer control or some machine control, robot control, they should pre-wet those threads before they get wound onto the cylinder. If you have any expertise on that, hey, let us know down in the comments what you think about that. Another question that we get asked a lot is, why is it so important about this descent rate of the sub, Jeff? Why were you so worried or concerned about it on the previous video where we talked about the Titan Sub transcript log going back and forth between the submersible and the boat? Why did I bring that up, and why was I so concerned about that? So you remember on that video that I uploaded where I talked about the transcript, I mentioned here Titanic's at 3,800 meters and the descent time given by OceanGate on their website, and even by what James Cameron and all of the other guys have done, it's 2.5 hours to get down to the bottom. And that leaves us here with a descent rate of 25.33 meters per minute. But what we actually saw was this. All of a sudden, the Titan Sub here shows up on the scene, and they're down at about 3,500 meters. So they're essentially 300 meters away. This would be the view that they would see if they could see. With, it's all dark down there. But the descent time was 90 minutes to get to that point. They arrived on site almost an hour early. They were an hour too fast. And so the descent rate was 38.8 meters per minute. Now, we're talking average. It doesn't necessarily mean that it's constant over time. So a lot of people kept trying to argue with me about this in the comments, that you can't assume it's constant this from the top or whatever. There's a lot of things here that control the descent rate here. The total weight of the craft, plus any kinds of density of the water at the time, the current flows. I mean, there's a lot of things. But what I was trying to drive home here, folks, was that during their entire trip, they shaved an hour off of that time. They descended too fast. So this is is probably the most common question we've gotten all week. I had an article where they interviewed a retired Navy submarine captain who said why, and I don't have it here to show you. I wish I could find it. I can't find it. A craft is supposed to go down under a known kind of a set speed where the pressures don't just increase on you all of a sudden like that. It's especially more important, I think, for this craft where you already had a questionable design and it was already known to creak and crack in the past when it went down on these dives. And so to send it down that fast, the pressure is just increasing at far too big of a rate, I think. And to me, it's too much of a coincidence that it was on this particular dive where it appears they were going down too fast is when the implosion happened. And remember, keep your questions coming because we'll answer as many as we can over the coming days. And thank you so much for joining us, folks, and we'll see all of you on the next one.